Okay, so we are now recording and welcome to our second part of the laboratory discussion, which will focus on the alkenes and alkynes. So this is just an extension of what you have learned last week. Okay, so last week we were able to have idea about the simplest form of hydrocarbon, which is alkane. Okay, and then today we will cover the other types of hydrocarbon, specifically our alkene and our alkyne. Okay, so again, just a reminder that in order for you to fully understand this topic, you should have mastered all the ideas in your alkanes. Okay, so the nomenclature for alkene and alkyne will be very similar with your alkanes, and the determination of chemical properties, physical properties will also be the same. Okay, so again, before you proceed with this discussion, I highly suggest you to master your alkanes first. Okay, so with that in mind, these are the topics that we will cover today. So we will focus first on the introduction, to be followed by the structure of your alkene and alkyne. Okay, and then the nomenclature, which is very similar with your alkanes, their physical property and the characteristic reactions. Okay, and then lastly, we will take a look into the industrial application of this topic, which is on the polymerization reaction. So let's start with the introduction. Okay, so we know that our alkanes, okay, so let's proceed first with alkane. Uh, So yeah, so we know that our alkanes, this is the simplest type of hydrocarbon. And in a sense, we sometimes call alkanes as a saturated hydrocarbon. So when we say saturated, it means that all the possible bonds of the carbon are utilized. Okay? Ibig sabihin, if it is tetravalent, okay, that means the carbon is bonded to four different atoms. Okay? That is the meaning of the saturated. Your carbon is bonded to four different atoms. Okay, so that's the saturated hydrocarbon. However, for alkene and alkyne, we call them unsaturated hydrocarbons. Unsaturated hydrocarbon. So they are unsaturated hydrocarbon. So what does that mean? So it means that there exists some double bond or triple bonds. Okay, so unlike alkanes, wherein all the bonds of carbon is connected to different atoms, for alkanes and alkynes, there exists a double bond or a triple bond. Okay, so whenever you have a double bond or a triple bond, we call it unsaturated hydrocarbon. Okay, so also in comparison with alkane, the general formula for alkane is CnH2n plus 2, alright? For alkene, its general formula will be changed to CnH2n. Okay, so wala na yung plus 2. Bakit? Because as I said, there exists a double bond, meaning there will be two bonds that are not connected to any hydrogens. Okay? Rather, it will be used to create bonds with the same carbon atoms. Okay? So one example of which is our ethylene. So ethylene is the simplest alkene, and this is the structure. So it has a formula of C2H4. Okay, as you can see, this carbon is bonded to only three different atoms, right? So this two hydrogen and this other carbon. Similarly, this carbon is also bonded to three different atoms. Okay, so this two hydrogen and that carbon. So since it only utilized three out of the four possible bonding with other atom, that means the extra orbital or the extra electron will be used to create the double bond. Okay, so What do we call the bond that is just used to connect with other atoms, and what do we call the bond that is used to connect with the same atom? Okay, so eh, um, the the bond that is used to connect to different atom is called a sigma bond. Okay, so meaning sigma bond is the electrons that are used, okay, to connect with other atom. In our case, this is a sigma bond to the hydrogen. This is a sigma bond to the hydrogen here, and the sigma bond to the carbon there. Okay, how about this electron here? Okay, so how about this electron here? That electron is called the pi bond. Okay, so that's the pi bond. Okay, so that's the pi bond. Okay, so why do we have a pi bond at all? Remember that in your hybridization, um, double bonds exist if you have an sp2 hybridized carbon. Okay, so if you have an sp2 hybridized carbon, then that means you will have your double bonds. Okay, so what is the meaning of sp2 hybridized carbon? It means that it utilizes only 3 out of the 4 hybridized electrons. Okay, so these 3 hybridized electrons are called the sigma electrons, which are used to create the sigma bonds. Okay, so this is the sigma bond, this is the sigma bond, this is the sigma bond. Okay, however, the unused electron is now called the pi bond. Okay, and usually the pi electrons, okay, looks like dumbbell because they retain their p orbital feature. Okay, so they retain the p orbital feature, which is dumbbell in appearance. Okay, so in our case, this dumbbell picture here is your pi electron. So this carbon here as well has 3 sigma electrons, which are used to create the 3 sigma bonds. And the unused electron, okay, or the pi electron, will look like a dumbbell as well. Okay, so as you can see, this electron is single. This electron is also single, meaning we can overlap them. We can connect them, and when they connect, they form the double bond. Okay? So originally, tigi-isa lang dapat yan. Okay? Tigi-isang bond lang sila. However, because we know that there will be one unused electron for an sp2 hybridized carbon, that means they can create this type of bonding. Other than the single bond in between the 2 carbon atoms, you will have another extra bond which is called the pi bond. Okay? So again, it's originally tigi-isa lang, pero in the presence of the pi electron, naging dalawa siya. Okay? So it becomes 2. So that is the reason why we have double bond. Okay, so the pi electrons are used to create the pi bond. And again, the characteristic of a pi bond is that it looks like a dumbbell. Okay, it looks like a dumbbell. So that's for alkenes. Okay, and then for alkyne, okay, so alkyne is another type of hydrocarbon in which you have a triple bond. Okay, so whenever we have a triple bond, the idea is that your atom is sp in hybridization, meaning that in the four in the four um, hybridized electrons, okay, only 2 of them will be used to create the sigma bond. Okay, meaning again, when we say sigma bond, these are the electron that will be used to bond with other atoms. Okay, so in our case, okay, so acetylene is the simplest alkyne. So the 2 sigma bonds are this one and this one. Okay, now how about the unused electrons. So similar with your alkenes, the unused electrons will be called the pi electron. Okay, so they will be called the pi electron. And again, how do they look like? So they look like dumbbell. Okay. However, how many dumbbells will you have if you have two pi electrons? You will have two dumbbells. So that's why the picture here for this carbon shows the two dumbbells. So this is the first dumbbell and this is the second dumbbell. Okay, so this one is one of the pi electrons, this one is one of the pi electron. Okay, and this carbon also is sp hybridized, meaning it is bonded to just two different atoms. So it used two of the four electrons as a sigma bond, and the other two unused electron will be used as the pi electron. Okay, so since we have two pi electron, then that means we will have two dumbbells as well. Okay, so may dalawang dumbbell ulit tayo. Okay, so ano ginawa natin sa dumbbells, no? What did we do to our pi electrons? In our alkenes, remember that our dumbbells, no, our pi electrons at can connect with each other. So when they connect with each other, there exists a double bond. So this is the first bond. This will be the new second bond or the double bond. Okay, so that's why we represent this as two lines. Okay, so what do you think will happen to your alkyne? Since you have two pi electrons, that means there will be two more extra bond between the carbon atoms. Okay, so that means other than the sigma bond here, other than the sigma bond there will be two more extra bond because we have two electrons each. Ito pati ito for this carbon, ito pati ito for this carbon. So those single electrons can also connect with each other. And how many bonds are there between these two carbon atom? So isa, dalawa, tatlo, creating your triple bond. Okay, so again, um, triple bond is just made when there are two pi electron. Okay, and then when they connect, magiging tatlo yung bond between these two carbon atoms. Okay, so 1, 2, 3, triple bond. Okay, so this is important, no? So again, if you have an alkene, the hybridization is sp2, meaning that there is one pi electron, okay, which is used to create one pi bond. Okay, so there will be an extra bond between the carbons, resulting to a double bond. While for alkyne, okay, there will be two pi electron. Okay, so those pi electrons will be used to create the pi bond, which means that other than uh, the single bond between these two carbons, there will be an excess of two more bonds. So that's why we have three bonds in total between these two carbon atoms. Okay, so that is your alkyne. Also, the formula for alkyne will be different. So it is CnH2n minus 2. Okay? So, ibig sabihin, when you increase the number of your double bonds, nababawasan si hydrogen. Okay? So, di ba, for alkane, that's CnH2n plus 2. Kapag alkene, mag-minus 2 ka lang sa hydrogen. And then for alkyne, another minus 2. Okay? So, yun. Minus 2 ka. Kasi yung electrons na yun, ginagamit sila for the double bond and the triple bond na eh. Okay? So, that is just one of the important things you have to remember about your alkene and the alkyne. Its hybridization Yung tawag sa sigma and pi electrons, and the sigma bond and the pi bonds. Okay? So again, pi electrons look like a dumbbell, and they can interact with the other pi electrons on the opposite atom. Okay? So they can create bond here, they create bond there. So in total, tatlong bonds yan. Okay? So that's your triple bond. Now, let's talk about the structure. So in your lecture, you know that depending on the hybridization, the structure of your hydrocarbon could change. So we learned that if you have an sp3 hybridized atom, that means the geometry will be always tetrahedral. However, if you have an sp2 hybridized atom, such as in alkenes, then you have what's called a trigonal planar geometry. Trigonal planar meaning that the uh, position of your atoms that are connected to the carbon will be separated at an angle of 120 degrees. Okay? So this is the top view. So this is the side view again. So this is the pi electron. For now, we will just simply ignore it. Let's look at the top view. So this is the picture. So as you can see, in the top view of your molecule, um, this carbon will be connected to three different atoms. Okay, so those three different atoms will be separated at an angle of 120 degrees. Okay, so in a sense, when you have sp2 hybridized atom, then that means it is trigonal planar. Okay, so it will be flat. So let me show you my molecular model for this one. So this is your ethene. Okay, so this is your ethene. And as you can see, you have your double bond here. One is the sigma bond, the other is the pi bond. Okay. So as you can see here, this carbon is connected to three different atoms. So one, two, three. And this one is also connected to three different atoms. So one, two, three. So as you can observe as well, the bond angle between this and this are all 120 degrees, making it a triangle. Okay, so it looks like a triangle. Also, it is flat. Okay, so that's why it's a trigonal planar. Okay, so whenever you have double bond, generally it becomes flat. Okay, so the carbons that possesses that double bond are flat in nature. Okay. Okay, so let's go back to the PowerPoint. Okay, so that's the idea. So again, if you have an sp2 hybridized carbon, the atoms are separated at an angle of 120 degrees. Okay, and that means the geometry of your molecule containing the sp2 hybridized carbon will be trigonal planar. So it looks like a triangle, but it is flat. Okay. And so because of this flatness, okay, or because of the presence of the double bond, the rotation of your uh, atoms will be restricted. Okay, let me show you my models again. So remember that in our discussion for the alkanes, since you have single bonds, that means the rotation is free. Therefore, you have different conformations for your alkanes. For example, this is the butane. This is the anti-conformation. If you rotate it, this will be the gauche conformation. This will be the eclipse. Okay. So those are possible due to the free rotation that can happen if you only have single bond, no? Madali lang siya iikot kasi isang line lang yan, no? Kahit anong atom, pwede mo siya iikot. Okay? Because you are not restricted in movement if you just have single bonds. However, okay, ito yung problema. In our alkene, Do you think we can rotate this? Pwede ba natin to ikutin? Siguro itong single bond, oo, yan o. I can rotate it. Okay? Kasi sabi ko nga, pag may single bond, you can rotate the single bond. How about these carbon atoms here? Can we rotate it? Okay, so suppose I have this atom here. Let me replace the hydrogen with a green atom. Let's say it's fluorine. So, can you rotate it so that this fluorine will be located down here? Let's try. Hindi kaya. It's not possible for you to rotate, okay, to rotate the double bonds. Why? Because the presence of extra bond causes restriction in the motion. Okay? So unlike single bonds, hindi ka restricted to move, no? It's like just barbecue stick. Dugtungan mo ng dalawang styrofoam. Pwede mo iikot-ikot yung mga bola. Okay? Such as I am showing here. You can freely rotate them because single bond lang yan eh. However, when you have double bonds, then you can no longer rotate it along this bond. Hindi na pwede kasi dalawa na yung nakatusok. Okay? So there will be strain in the bonds. Okay? It will be difficult to do that. Okay? So, ibig sabihin nun, wala tayong conformation for your alkenes. Okay? Kasi yung alkanes, may mga conformation yan eh, no? We have the eclipse, okay, the anti, the gauche, something like that, okay? However, for alkenes, because the rotation is not possible, ibig sabihin, edi walang rotation, wala tayong conformation. Instead, what we have is isomerism, okay? So, isomerism is again, just as we said, that is just molecules that have the same formula but they differ in the connectivity. So suppose I have the two green atoms located on top of the double bond. So this is the double bond, yung green atoms ko nasa taas. Is it the same as this one? Is it the same as this one? Yung isa nasa taas, isa nasa baba. Are they the same? Compared sa nasa taas yung isa, nasa baba yung nasa ngayon. They are different, okay? Kasi again, isomer yun, okay? So isomer yun because they are the same in terms of the formula, but in the connectivity of the atoms, it is different, no? Kanina, both of the green atoms are on top. Ganito siya kanina. However, ngayon, lipat ko to dito sa baba. Iba na siya. Okay? So, iba na siya. So, what will we call the isomerism for the alkene, if that's the case? We can use the cis-trans isomerism. Okay, cis, ibig sabihin, parehas sila nasa same side with respect to the double bond. Trans, meaning if they are on the opposite side of your double bond. So, for this molecule here, what is this? Is this a cis isomer or the trans isomer? This one is a trans isomer. So again, we always determine the isomerism with respect to the double bond. So this will be our baseline. So as you can see, one atom is on top of the double bond while the other one is on the opposite. Ibig sabihin nun, kapag opposite yung kanilang positions, that is trans isomer. Trans isomer yan. However, if they are both on the same side with respect to the double bond, so this is your double bond. If they are both on the same side with respect to the double bond, meaning this is your cis isomer. Cis, ibig sabihin, same side. Trans, ibig sabihin, opposite sides. Okay? So yun lang, wala tayong conformation for alkenes. Rather, what we have is the isomerism. Okay? So just the isomerism lang. The cis-trans isomerism. So in this PowerPoint here, okay, what we have is the cis-butene and the trans-butene. Trans-2-butene, cis-2-butene. Okay? So why is this cis-2-butene? Because the two methyl groups are on the same side with respect to the double bond. So that is your cis-2-butene. While if you place the methyl on the other side with respect to the double bond, okay, that will be trans. Okay? So pag nasa same side, yan ay cis. Pag nasa opposite side with respect to the double bond, that is your trans. Okay? So, for alkynes, wala nang cis-trans isomerism. Bakit? Ano ba yung position ng mga atoms mo? Nasa linear lang siya eh. Okay. So, for alkynes, since the hybridization of your carbon is just sp, meaning that the two atoms are positioned on the opposite sides lang, no? Isa sa left, isa sa right. And they are separated by 120-degree angle. Keep in mind that there are three bonds between the carbon atoms for an alkyne. Okay? Tatlo yung bond niya. One of which is the sigma bond and the two other are the pi bonds. Okay? So, it is linear. Wala nang cis-trans dito kasi isa lang naman yung mga atoms na nandyan. Okay? So, you fix na yung positions nila. However, for alkene, doon tayo may cis-trans isomerism. Okay? So again, for sp hybridized, that will be 180 degrees in bond angle separation, and the geometry will be linear. Okay, so that's it. No? So yun yung introductory part lang natin. So now, let us proceed with the nomenclature. So just a disclaimer, if you have not fully understand the nomenclature for alkane, I highly suggest you to study it first, okay? Because as long as you know the nomenclature for your alkane, then the nomenclature for alkene and alkyne will be much easier because they follow the same rules, no? Same rules lang but with some modification. Okay? So, yun lang yung disclaimer again. So, if you are okay with the nomenclature of alkane, then you can proceed. Otherwise, you have to review it muna. Okay. So now let's proceed, assuming that you know how to name the alkanes already. So, in the nomenclature of your alkene and alkyne, it is very similar with the nomenclature for your alkane. Okay. However, there will be some minor changes. Okay. So, ito yung mga rules natin. So, first is that, of course, you have to identify the parent chain. However, in identifying parent chain, okay, you need to include the double bond. Okay? Isama nyo yung double bond when you count the parent chain, when you identify the parent chain. Okay? And then, once you identify the parent chain, okay, other rules are the same lang. Identify and name the substituent. You assign the locant. However, this is your priority na. Hindi na yung substituents lang. You also need to prioritize the locant for your double bond. Okay? Kasi in the alkane, what we just prioritize is yung substituent. Okay? However, in alkenes, we need to consider also the double bond. Okay? So, the double bond must always be prioritized over the other substituents. Okay, then after that, you will list your substituents with their corresponding locants or number, and then after that, you can combine them. However, the parent name for the alkene does not end with the ane suffix. No? It does not end with the ane. Kasi kapag sinabi nating ane, that's alkane. Okay, so for an alkene, if you have a double bond, the ane should be converted to ene. Okay. So again, the rules are very similar. Okay. However, with just a minor tweak. Ano yung mga tweaks na yun? You need to include the double bond and you have to prioritize the double bond in giving your locants. Okay. Yun lang. And instead of using ane for the parent chain, you need to use the ene, okay? Because this is alkene, okay? So let's have some examples here. So step one, okay? So you need to identify the parent chain, and as I said, instead of using the ane suffix, because you have a double bond, you will need to use the ene suffix, okay? So yun lang. So the parent chain should include the C double bond C, okay? So for example, here, okay, so if you don't have any double bond, then this will be your longest chain, right? So it will be octane. However, since in this molecule on the right, we have a double bond that is in here, okay lang kahit hindi na siya yung longest as long as it will contain the double bond na okay lang yan as long as madadaanan niya yung double bond. Okay? So, yun lang. And then after that, you need to identify and name the substituents. We already did that in the alkane, so we'll skip with that. Number three, we will assign the locant. Again, you need to prioritize your double bonds, okay, first than your substituents. So, unahin mo muna yung double bonds sa locants, not your substituents, okay? So for example, we have this same molecule here, but the numbering is left to right for this one, and this one's right to left. Okay. So ano nangyari? Ang nangyari is that, as you can see, this one is wrong. No? If you prioritize your substituent, mali yun. So again, the priority for alkene is to give your double bond the lowest number. Okay. So this should be prioritized first over the others. Okay. And then also, um, the locant to be used should be the carbon number where the double bond starts. Okay? Kung saan nag-start yung double bond, yun lang yung gagamitin mong number. Kasi baka mamaya gawin nyo dyan 2, 3, no? Hindi ganyan. You will just indicate to which carbon number did your double bond started. Okay? So, carbon number 2 lang yan. Okay? So, yun. Don't worry, we have many examples later. Step 4 is again, after identifying and numbering your substituents, then you can alphabetize them. Ignore the hyphenated substituent names such as the sec and the tert. However, for iso, it needs to be included. And then lastly, ayun. So instead of using ito, hindi pala. So the last step is this now. Since you need to include the number of the carbon where your double bond will be located, there are two options in writing it. You can write it before the parent name, or you can write it before the suffix in. Okay? So, pwede tawag dito 2-heptene or pwede rin namang hep2-ene. Both are same lang. Pero I highly suggest you for simplicity that we use this one lang. Okay? So, 2-heptene, ibig sabihin yung double bond nasa carbon number 2. Although in college, I preferred this. Pero, you might be confused na kaya eto na lang. So anyway, both of them are the same lang naman. Okay? But for now, let us use this. The locant for your double bond must be written before the name of the parent. Okay? So we'll use this one on top. So, so let's name the alkenes. So, in the pictures here, ano meron dito? For cycloalkenes, paano ka magna-numbering? Okay? So, zoom tayo dito. So, let us focus on this picture here. So, in the picture here, the numbering is shown as 1, 2, 3, 4, 5, counterclockwise. The other way of numbering it will be this, okay? So, let me use a different ink color. So, I will begin first with this one. 1, 2, 3, 4, 5. Okay? So, yun yung two ways of numbering it now. So, again, you always start before the double bond. So, 1, 2, 3, 4, 5. Pwede rin naman dito. 1, 2, 3, 4, 5. Okay? So, which one will be used? Is it the red or the blue? So, apparently, yung red na nakasulat. Okay? So, why? Kasi, if we count counterclockwise, the substituent will have a locant of 3. However, if you count it clockwise, then your substituent will have a locant of 5. And which is lower? Is it the 3 or the 5? Obviously, it's the 3. Okay? So, yan. So, we need to do it counterclockwise. So, you should not begin here, ha? Hindi ito yung carbon 1. Okay? Instead, you start before the next carbon atom. Okay? So, dito, 1, 2, 3. Okay? Baka isipin nyo 1, 2, mali yan. You should include the next atom that is double bond. Okay? So, same idea here. Okay? So, same idea. So, ito naman. This one's much easier. So, if I count, if I assign locant, so again, I will normally give my double bond the lowest number, right? So, 1, 2, 3, 4, 5, 6. Okay? So, pwede ka rin naman mag-count counterclockwise. So, ito yung 1, 2, 3, 4, 5, 6. What is the problem when you count counterclockwise? Okay, so 1, 2, 3, 4, 5, 6, the one in blue. If you count counterclockwise, then your substituents will have a locant of 2 and 5. Okay, so sa 2 may methyl, sa 5 may ethyl. However, if you count it clockwise, 1, 2, 3, 4, 5, 6, if you count it clockwise, then your locant of the substituent will be 1 and 4. So which is lower? Is it the 2 or the 1? Is it the 5 or the 4? So obvious answer will be the 1 and the 4. Okay? So that's why we will choose the clockwise counting. Okay? So if you have multiple double bonds in your alkene, then you need to indicate how many double bonds there are. Usually, the number of double bonds are indicated before the suffix of the alkene. Okay? So, ano ba yung suffix ng alkene, Eddie? In, di ba? So, you need to indicate the number of double bonds using a Greek prefixes before the suffix in. So for example, in this molecule here, I have two double bonds. So I will call it diene. Okay, diene, dalawang in. So two double bonds. Okay. So such as this one here. So you have two double bonds here. So that's why it is called diene. What if tatlo yung double bond? So tawag doon triene. Paano kapag apat, edi tetraene? Okay, so ganun. Okay, so yan. So again, you will just need to indicate the number of double bonds before the suffix in. Okay, so one example here will be the 1,3-cyclopentadiene. Okay. Di meaning dalawa ang double bond. In kasi alkene siya. Okay, so ganun lang. For alkyne, you will follow the similar rule. Same lang din sa alkene virtually. However, you prioritize the triple bond first. Na? Triple bond muna kaysa sa double bond. Also, instead of using the in suffix, you will now use the the ein suffix. Okay? Ein. Kaya nga ein yung alkyne. Okay? So, in kapag alkene, ein kapag alkyne. Okay? So, that indicates the presence of your triple bond. Some of the alkynes have common name, such as shown below. So, ethene, common name niyan is the ethylene. Okay? Saan nyo naririnig yung ethylene? Okay, so, ethylene is apparently a ripening agent sa ilang prutas. Di ba? So, that's why minsan if you place the mango in rice, no, nag-emit yun ng ethylene. So, yan. Nag-ano siya, nagra-ripen. Propylene, okay? So, propylene, the common name, the IUPAC name for that will be 1-propene. 1-propene lang pala. Okay, so yan, propene lang. Okay, so the common name is propylene. So, saan ginagamit yan? Sa torch. Okay, propylene torches. For the alkyne, what we have here are the following. So, ethene. Ethene. Okay, so depende how you pronounce it. So, pwedeng ethine, ethene, ethine. Nabulol na ako. So, ethine siya. Okay. So, that will be ethine. Ito yan. And the common name for that one is acetylene. Okay, acetylene. Do not confuse kasi baka isipin nyo, acetylene in yan. So, alkene yan. No. I don't know the reason behind this. Why they call it acetylene. I don't know the reason. Okay? Pero yan. So, don't confuse yourself. Pag sinabing acetylene, that is just the common name for your ethine. Okay? So, it's not an alkene. Rather, it's an alkyne. Saan ginagamit yung ethine or the acetylene? It's used in torches as well. Okay? So, yan. So again, as you can see, the nomenclature for your alkene and alkyne resembles that of your alkanes. Okay, so again, if you have not mastered your alkanes yet, then this is the time for you to review it first. Anyway, we will be uploading some practice quizzes this weekend, so that you will be prepared for your upcoming quiz next week. So with that in mind, let us answer some of the problems. So I will not answer all of them as the answers are already provided in the PowerPoint. So I highly suggest you to download the PowerPoint in Canvas. Okay? Kasi may answers done. But again, I will not answer all of them. Okay? Just some of the important easy molecules lang. So siguro in our case, I will just answer A, B, and C. Okay? So allow me to do that. I will just answer A, B, and C. For D, E, F, G, H, the answers are already in the PowerPoint. So if you download them, it will look like this. You can pause the screen if you want. Okay. Anyway, let me bring it back here. Ayan. So, ayan. With that in mind, I guess we can start na. Okay. So again, I will just answer items A, B, and C. So let me use my whiteboard. Okay. Let's use the whiteboard. Snip it. Oopsie. Okay, so there we go. We have our alkenes here, alkenes. Okay. So again, I will not answer all of this, those in the PowerPoint, only these three. So let's begin with this letter A. Okay, so what do you think is the name of this one? Okay. So how will you know its name? Okay, madali lang. So first you have to identify the longest chain that includes the double bond. So it should include the double bond, okay? So in our case, madali lang yan. So ito yung longest chain. Ito ba yan? Or ito? Yan ba yan? Or ito? What do you think is the longest chain? The yellow or the green one? Bilangin natin. If you follow the yellow highlighter, 1, 2, 3, 4, 5, 6. So that will be 6 carbon. While if you follow the green ones, ilan yan? 1, 2, 3, 4, 5. So 5 carbon. So obviously we will follow the yellow one. Okay? So the yellow one will be used. So now, after highlighting your parent chain, of course you have to name it. So since we have 6 carbons here, then that means the name of the alkene here is what? That is hexene. Okay, so that will be hexene. Hindi siya hexane. Baka sabi nyo, ay hexane po. No, it's not hexane because you have a double bond here. So the ane needs to be converted to ene. What's next? So that's your parent. Next is that you assign locants. Okay, so this is your substituent and this is the double bond. When assigning locant, again, always keep in mind that your double bond must be prioritized first. Okay, so it should be prioritized. So if we count from here to there, from right to left, your double bond will start at carbon number 3. Okay, and let me continue the numbering. Yan. However, if we count from left to right, saan mag-start yung double bond mo? Still in the carbon number 3. So, in both directions, the locant for your double bond will be 3. Okay? So, wala tayong problema doon in our case. Kasi parehas yan 3, both directions. Ngayon, where is the problem? Your substituent. Okay? So, ang problem is that, how about your substituent? Kasi, if you use the left to right, okay, your substituent will be in locant number 3. While if you use the right to left counting, it will be 4. So which one is short? Which one is lower? 3 or 4? Obviously, yung 3 yon, of course. So that's why we won't use the red ones. Okay. So instead, we will use the blue numbering, the one that is left to right, kasi yung ating substituent falls on the lower number. Okay? So the name of this substituent will be 3-methyl. So what is the complete name? The complete name. So of course we have one substituent lang, so you can write it agad, no? So 3-methyl followed by your hexene. Hexene ba agad 'yon? No, hindi. Again, just as I said, you have to include where the double bond started. Saan nag-start yung double bond sa hexene? So where did it begin? In carbon number 3. So you have to include that. You have to place the locant of your double bond before the parent name. Okay. So the name of the molecule is 3-methyl 3-hexene. You can also name it this way. You can also name it this way. So 3-methyl hex 3-ene. And sinabi ko to kanina, right? That you can place the number before the "-ene" suffix, or you can place the number before the parent name. However, I highly suggest that we use this one. Although this is correct, Pero wag na natin ito gamitin because apparently it uses many dashes, you know. Again, why do we have dashes? If you have a number and a letter for the IUPAC nomenclature, you have to separate them with dashes. Okay? So, this one will be used. So, kapag nag-type kayo ng quiz, ng answer sa quiz or sa practice quiz, ganyan dapat. Okay? So, no spaces, only dashes and comma. And the locant for your double bond or your triple bond should be written before the parent name. Okay. Let's proceed with the next one. So this one's kind of interesting. Where is our parent chain here? So again, it should always include the double bond. So we can consider this, oopsie. We can consider this as a parent chain. Okay. Marami tayong variety dito. We can consider this as the parent chain. We can also consider this. And same lang pala yan. So whichever you go, same lang din yan. Pares lang. We can also use this as our parent chain. Ito yung tanong. Sino yung susundan? Is it the yellow or the green one? So obviously, we will use the yellow one again. Okay? We'll use the yellow one kasi for the yellow one, you have 5 carbons. So this is 1, 2, 3, 4, 5. However, if you use the green one, 5 carbons din. Hala. Okay. Paano na siya naging hala? Okay. So 5 carbons din pala yung green one. Ano nga lang yung difference? The difference is that if you use the green one, you will have a complicated substituent. We don't like that. Sabi natin, di ba? We always choose the parent chain that has more substituent. If we use the green numbering, okay, so the green one, isa lang substituent mo. While, if you use the yellow one, maging dalawa substituent mo. So, the more, the better. The more substituent, the better. Yun yung idea when you identify the parent chain. Okay? Again, although they are both 5 carbons, we will choose the yellow one instead of the green one. Because apparently, if you choose the green one, you will just have one substituent. However, if you use the yellow one, you will have 2 substituent, which is preferred. Okay? So let me just control Z everything. Yeah. So we have this thing here. Now, since you identify the parent chain, what will be the next step? The next step is to assign the locant. So in assigning the locant, you have to do it in 2 directions first. Okay? So 1, 2, 3, 4, 5. And the other one is starting at the rightmost side. Okay? So, again, our priority is to give the double bond the lowest combination, the lowest number. Okay? So if we count from left to right, our double bond will start at carbon number 2. While when we count from right to left, our double bond will start at carbon number 3. So which one is preferred? Is it the 2 or the 3? So the answer will be the 2. Okay, so the 2 will be preferred kasi sabi natin we should give the lowest number for that double bond, okay, to the carbon that will begin that will start the double bond. Okay, so we'll use the red numbering. Okay, so meaning I need to discard this na lang. So let me just discard those and redraw the parent. So we have a methyl here. So everyone knows that. And this is ethyl, that's 2 carbon. And the ethyl is in carbon number 3. The methyl is in carbon number 4. And we need to alphabetize it. Which one should come first? Is it the ethyl or the methyl? Uh, Alphabet song lang yan. A, B, C, D, E. Okay? So you first write the the ethyl followed by the methyl. Okay? Because E comes first in the alphabet followed by the M. Okay? So the complete name will be ethyl muna followed by the methyl, and that will be followed by what? Ito na naman. Ilalagay ko ba pentene agad? No, that's wrong. Why is it wrong? Because I have to indicate the carbon where the double bond begins. Okay? So, saan ba nag-start yung double bond? In carbon number 2. So, I have to write it before the parent name. Okay? So, instead of writing pentene agad, you have to indicate 2 followed by the parent name. So, the complete name of this molecule will be 3-ethyl, 4-methyl, 2-pentene. Okay? So, yan. Last one. For the alkene, last one. Marami pa tayong i-cover. Ayan. Oops. Something happened here. Okay, so for letter C, this one's kind of weird. Okay. So what should be our parent chain? Should it be this one? Yan ba yun? Ito ba yun? Okay. So yun lang naman yung pwede. It's either the yellow or the blue one. So, in order for us to decide, let's count which of them will have the greater number of carbon atoms. So if we use the yellow, can I change it to yellow? So that will be 1, 2, 3, 4, 5, 6. So for the yellow one, we have 6 carbons. However, for the cyan one, we have how many carbons? So 1, 2, 3, 4, 5, 6, 7. So the cyan color bears more carbon atoms. Okay, so that's why it will be preferred. Okay, so yun yung gagamitin natin. So the blue one. Okay, let me erase everything. We'll use the blue one. Palitan ko na lang uli ng color to yellow. Now, once you identify the parent chain, ilan to? 7, di ba? 1, 2, 3, 4, 5, 6, 7. So let's have 10. Okay. So after identifying the parent chain, you need to assign locant. So assigning locant, left to right, right to left. Okay. So I'll use the red one for the left to right numbering. And for the right to left, that would be the blue one. Okay, so both 7, okay. So what will be our preferred locant? Okay, is it the left to right, the red one, or the right to left numbering, the blue one? So the answer should be the red one. Bakit red? Kasi our double bond starts at carbon number 2 if we use the red numbering, while the double bond will start at carbon number 5 if you use the blue numbering. And of course, 2 is lower than 5, so we prefer the red one, okay? So we will choose the red one. So as you can see, the double bond begins at carbon number 2, so you can write it as 2-heptene. What else? Your substituents. So this is 2-methyl. This one's 3-methyl. And this one's 5 methyl. So as you can see, you have three methyls group. You can combine them. So how will you combine them? So basically, you just combine the numbers using a comma. And since you have three methyl, you have to write down trimethyl. Okay, so this is your overall substituent, the 2,3,5 trimethyl. Okay. You can combine them, right? So that's not the final answer because we forgot the parent chain. So again, for the parent chain, that should come after the substituent's name. So the complete name will be 2, 3, 5 dash trimethyl 2 heptane. Okay, so that will be our final answer. Okay, so again, the rules for the alkanes are very similar with the alkenes, right? Parehas lang. There are just some minor modification, of course, in terms of the priority. Uh, in the in the alkene, we give the double bond the higher priority instead of the subs. Sorry, instead of the substituents. Okay. For the alkynes, still the same rule as alkenes. Okay. So still the same rule as alkenes. So basically, I will just try to answer. Ano kaya pwede? ABC na lang din uli. Ayan. And just only two items na lang. Kasi same lang ng rules eh. Siguro I will choose. Wait lang. So, C and D na lang. Okay? So, I will answer C and D. Again, the answers for the other items A, B, E, F, G, they are included in the PowerPoint. So please download the PowerPoint that is uploaded into your Canvas accounts. Okay, so just download it. So for the alkynes, I will just answer two items. So that will be these two. So these are two alkynes, so let's name them. So for letter C, this is just a plain molecule here. So nothing much is very interesting anyway. So the problem here is where we should count. Okay, should you count left to right or right to left? Okay. So when you count from left to right, the double bond will start at carbon number 5. While if we count from right to left, the double bond will start at carbon number 3. Obviously, this one is preferred over the 5 because 3 is lower than 5, right? So the complete name for this one is simply 3-octane, okay? So again, ine, no? Diba? Ane kapag alkane, in kapag alkene, but since we have a triple bond, we will use the ine. Okay, so 3-octane. Meaning that the triple bond started at carbon number 3. How about this one? So this one has substituents, obviously, and what is the longest chain? So the longest chain will be this thing. Pwedeng ganyan. Pwede rin naman dito. Same lang naman. Okay? So I will choose this one. How many carbons are there in your longest chain? So this is 1, 2, 3, 4. The other way of numbering will be the right to left. If you count from left to right, your triple bond will start at carbon number 1. While if you count from right to left, your triple bond will start at carbon number 3. So the obvious preference for this one is the left to right numbering because 1 is lower than 3, obviously. Okay, so we will use the left to right numbering. So the parent name will be 1, this is butane. That's 1 butane. Then you have your 2 methyl substituents in carbon number 3. So the complete name will be 3,3 dimethyl 1 butane. Okay? So, ganun lang ka-easy. Very easy. As long as you know how to name alkanes. Because if you don't know how to name alkanes, then that will be a problem. Okay? So, go study alkanes first before you study this. Okay, so actually that's all for the nomenclature. Okay, so that's very easy now. So let's proceed with the next part of our topic. Let's talk about the physical property of alkene and alkyne. Okay, so generally speaking, the physical property of alkene and alkyne doesn't really change no, compared to alkane. No? Hindi sila iba-iba. Parehas lang sila. So, ibig sabihin, alkanes, alkene, and alkynes share the same physical property. No? That since the bonds are non-polar, ibig sabihin, they can only exhibit London dispersion forces. Okay? And as we know in alkanes, as you increase the carbon chain length, then the melting point and the boiling point increases. Okay? Due to the more number of electrons. Also, similar with alkanes, alkene and alkyne tend to have lower London forces when you have branched alkene and alkyne. Okay? 'Di ba sa alkane, kung naalala nyo pa, um, the more branching you have, the lesser the forces of attraction because the molecule gets smaller. Okay? So it have lower surface area kasi. Okay, so that's basically for the physical property of your alkene and alkyne. It's very similar with your alkane. Also, it is nonpolar, so it will not dissolve in water, and apparently its density is also lesser than water, meaning that alkane, alkene, and alkyne will float on top of the water. Okay, now let's talk about the last part of our discussion, which is focused on the characteristic reaction of alkene and alkyne. Alkene and alkyne work very similarly. Okay? Kasi para silang may pi bond. Okay? And the pi bond have the characteristic reaction. Okay? So the characteristic of reaction of our pi bond is shown here. Okay? Usually, pi bonds, such as double bonds and triple bonds, do undergo what's called an addition reaction. What happens when you have an addition reaction? So basically, the molecule that you are reacting with, your alkene and alkyne, will just be added to the double bonds. So basically, this double bond will be broken, and then the atoms X and Y will be connected to it. Okay. So kaya siya tinawag na addition. Okay. Yung dalawang group of atoms mo na reactant, idudugtong mo lang siya sa double bond. So basically, in a sense, yung alkene natin, hindi na siya alkene. So hindi na siya may double bond. Okay? So yun. So the following are the characteristic reaction of alkene. Okay, so it shows the addition reaction, and just as I said, ang nangyayari lang in your addition reaction is that your atoms get connected no, to the double bonds. So for example, the H atom will get connected here, the Cl atom from the HCl will get connected there, and the double bond will be destroyed. Okay, so when you have your HCl connected to your alkene, we call that hydrochlorination. If you use water instead, the atoms that connect are H and OH as a whole. So the H will connect here, the OH will connect there. Okay? So since you have an OH functional group, then it is an alcohol. Okay? So that is your hydration process. Ganun lang. No? So again, yung water, that should be written as H and OH. No? The two are separated. For Br2, okay, so for Br2, you can write it as Br, another Br. So basically, this Br will be connected here. This Br, the second Br will be connected there. Okay, so that's called the bromination reaction. And then lastly, the hydrogen gas, similar with the Br2, yung parehas na hydrogen, it will get connected to the carbons, causing your alkene to be an alkane. Okay? So, ganun lang ka-simple. So, those are the addition reactions. No? Madali lang, no? However, let's take a look into what actually happens. Let us show the reaction mechanism. When we say reaction mechanism, it is just a detailed way of writing what's happening in the reaction. It shows the way this atom is connected to this. No? Why is this connected to that? Okay, so the reaction mechanism will show that. So again, the reaction mechanism is just a way of showing the exact the exact swapping of atoms in the chemical reaction. So the reaction mechanism for addition reaction follows a concerted process. When I say concerted process, it means stepwise process, no? So, ibig sabihin, may steps tayong susundin later. So, what's the first step in addition reaction? So, the first step in addition reaction is that your double bond acts as the nucleophile. Nucleophile, let's dissect the word. Phile, ibig sabihin, it loves. No? Nucleo, ibig sabihin, nucleus. What's nucleus ba? It is positive. So basically, your double bond loves a positive atom. A partial positive atom. Okay? So, yan yung idea natin. Yung double bond, gusto niya ng partial positive atom. Okay? So in the molecule here, this is H and X. X is any halogen, let's say fluorine. Yung H, yun yung partial positive. While the halogen, the X, yun yung partial negative. So what will happen is that the double bond will get that. So madudugtong siya. Okay? Dudugtong yung H doon. However, when we show this arrow, ibig sabihin may bond na mabubuo. No? And since isa lang yung bond na kaya ni hydrogen, then that means we need to give this up. Ibibigay natin siya sa katabi niya, yung electrons dyan. Okay? So yun yung meaning nito. This double bond will be destroyed and magkakaroon tayo ng bond to hydrogen. Since isa lang yung bond na kaya ng hydrogen, we need to return these electrons to the halogen. Remember that for a single line, there are 2 electrons. Okay? Kaya naging 8 yung dots niya dyan. Okay? Nag-octet rule siya. So this is what this diagram mean. Kukunin niya yung hydrogen. So, dudugtong na yung hydrogen dito sa any of the carbons here. Could be here, could be here. And then, since isa lang yung kaya ni hydrogen na bond, this must be returned to the halogen. Usually in the form of lone pair. Ngayon, ito yung dilemma. Saan mapupunta yung hydrogen? Is it 1 or the 2? In our case, skip muna natin kasi mamaya pa natin yun ipapakita. Okay? So, in our case, kunwari dito muna siya sa 1 kakabit. So, yun na siya. So, what will happen? So, itong carbon na to, dito nadudugtong yung hydrogen. Itong isa, kulang siya ng atom. Kulang siya ng atom. Kulang siya ng bond. So, kapag kinulang ng bond yung iyong carbon, we call it the carbo-cation. Okay? Carbo-cation. Okay? That is your carbon na kulang ng bonds, okay? Meaning it is positive. Okay? So that's the first step of the addition reaction. Your double bond will act as a nucleophile, meaning it will abstract the hydrogen. So as it abstracts the hydrogens, you will produce your carbocation and the anion. Ito yung carbocation, the carbon that is kulang ng atom, and this is the anion. Okay, so we have some terms that you need to remember here. An electrophile is an electron-poor species. Phile siya. So, ibig sabihin, it loves electron. So, kung mahal mo yung electron, ibig sabihin, kulang ka sa electron. Di ba? So, yan. So, when you say electrophile, sila yung mga electron-poor. While a nucleophile, sila yung kulang ng positive. So, they love positive atoms. They are electron-rich. Negative sila na gusto ng positive. Okay? So you will encounter these two terms in succeeding discussions on organic chem. So ngayon, what we have after the first step is the carbocation and the anion. And as we know that positive is attracted to a negative. Positive si carbocation, negative si anion. So ano mangyayari? Magdudugtong lang sila. Okay? So they will just connect. Okay? So producing your final product. Ganun lang. Very easy, right? So first, kukunin si hydrogen. Magpo-produce ka ng carbocation and the anion. And then the next step is that your anion will attack the carbocation so that a new bond will be formed. Ganun lang. Very easy. Okay, so for the first reaction, that's hydrohalogenation reaction. Hydrohalogenation meaning it has a hydrogen and a halogen. So the X could either be fluorine, chlorine, bromine, or even iodine. Okay? So yun yung hydrohalogenation. Hydro meaning hydrogen, halogenation meaning pwede fluorine, chlorine, bromine, iodine. Okay? So, yun lang yung hydrohalogenation. So, let me show you how can we determine the products. Okay? Let me show you how you should write the reaction mechanism. So, in showing the reaction mechanism, it is just 2 steps. Okay? Dalawang step lang yan. The first step is that your double bond, the pi electron, will abstract the hydrogen. You usually represent it that way. So, ibig sabihin yan, pag pinakita mo yung arrow na yan, it is pointing towards the hydrogen, which is yung kukunin natin. Magkakaroon na ng bond with hydrogen. Okay? And then, itong electron na to, since isang bond lang yung kaya ni hydrogen, kailangan niya i-give up to. Okay? So, it needs to give up this electron and this must be given back to bromine. Let me just show the lone pair. I forgot to include the lone pairs pala. This is the Lewis structure. Yung electron dyan, balik mo kay bromine. So, ano mangyayari? So, you will have this. Okay, so saan mo ilalagay yung hydrogen? For now, the molecule is symmetrical. Symmetrical, ibig sabihin, same sa left, same sa right ng double bond. So, kahit saan mo pwede ilagay yung hydrogen. Dito na lang. And this carbon here, remember, may carbon dyan. Since tatlo lang yung bond niya, okay, may hydrogen dyan, remember. It will be a carbocation. Okay. So, again, baka nalito kaya. Yung hydrogen, pag symmetrical yung molecule mo, ibig sabihin, same yung left and right. Same lang siya. Kahit saan mo pwede ilagay yung hydrogen. Pwede nandyan, pwede andito. Ako, I prefer na nandito siya. Okay. So, yan. Ano mangyayari dito? Magiging carbocation yan. So, you indicate the carbocation with a positive sign. And then what else you will produce? Okay, so these electrons will be given to bromine. So magiging an ion na siya. with 8 lone pairs. Bakit 8? Kasi one single bond contains 2 electrons, right? Lewis structure. If you forgot that, you need to recall that again. What's next? Ano mangyari? The negative anion will attack the carbocation. How should you draw the arrows? When drawing the arrows, madali lang yan. Let me just fix this. When drawing the arrows, you usually begin with the lone pair. So begin ka with the lone pair, and then you connect it to the carbocation. Ganun lang. Okay, so from the lone pair to the carbocation. And then you can show this final product, wherein the bromine will be connected here, and the hydrogen is connected here. Okay, so ganun lang. In the drawing here, the hydrogen is not included as dapat automatic na yan. Alam mo na na may hydrogen doon. Okay? So, ganun lang. If symmetrical ang inyong alkene, then you can place the hydrogen anywhere. Pwede sa left, pwede sa right. Okay? And then yung hindi nadagdagan ng hydrogen, carbocation yan. Ito yun. And then ano mangyayari sa carbocation? Dudugtong doon yung anion mo, which is your halogen. Dudugtong yan, so you will have this product. Now, the question is, what if hindi po symmetrical yung alkene natin? When you say hindi symmetrical, ibig sabihin hindi siya pantay. Okay? For example, we have this thing here. Is this alkene symmetrical? So, hatiin mo sa gitna yung alkene. Itong nasa left ba is same with the one on the right? No. Magkaiba sila ng itsura. Pero kung ganyan yan, same lang, di ba? Pero na, hindi eh. Ganito lang. The question here is, where will you place the hydrogen? We know that this pi electron will get the hydrogen. Pero saan mo siya ilalagay? Should I place it here? Or should I place it here? Anong sagot doon? So if this is the problem, you have an asymmetrical alkene. Asymmetrical, ibig sabihin non-symmetric. Then there will be 2 regioisomers possible. Okay? So regioisomer meaning ng regioisomer, region, pwede na sa left, pwede na sa right. So susundin natin. So apparently, if you have this case, you should place the hydrogen daw in the carbon atom that contains more hydrogen. Sino ba dito yung mas maraming hydrogen? Ito or ito? Is it the 1 or the 2? Obvious answer is yung 1. Okay? Kailangan marunong na kayo mag-count ng hydrogens. Okay? So, ito mas marami itong hydrogen. Ano yung technique na pwede gawin natin dyan? Bilangin mo yung bond to this carbon. Ilang bond ba meron dyan? 3. 1, 2, 3. So, kung 3 bond yan, edi, yung isang bond, kay hydrogen yan. Okay? May isang hydrogen dito. Dito, ilang hydrogen meron dito? Wala. Bakit? Kasi 4 na yung bond ni carbon. So, hanggang 4 lang. So, wala kang hydrogen dito. So, apparently, if ganito daw yung case mo, you have an asymmetric alkene, you should place daw the hydrogen to the carbon that bears more hydrogen. We call that rule the Markovnikov rule. Okay. The Markovnikov addition, wherein the hydrogen will be placed to the carbon atom bearing more hydrogen. Okay. So again, by just looking, you should be able to identify kung ilan na yung hydrogen sa carbon na yan. Okay? So, yun yung idea ng Markovnikov addition. The hydrogen will be placed to a carbon with the most hydrogen, and the halogen is positioned to the carbon with the most substituents. Okay? So, ganun lang. So with that in mind, let us try to answer the following items. So sagutan natin lahat. Okay? So to make sure na naintindihan. Okay. So I think I need to use the whiteboard again. so that I will have more space. I will not answer all of them na lang pala. So, tatlo lang. Dalawa lang. Though I will show the answer. For number 1, this is our question. Okay. So, you have your alkene. Okay. So, this is 1-methyl cyclo 1-propene. Okay. So, yan. So, dito yung carbon number 1 mo. Okay, so anong mangyayari dito? What will happen here? What will happen here is that you know that the double bond will get the hydrogen. Let us draw the lowest structure of HBr para mas maganda. Okay, para mas kita nyo. Okay, so the first step is always that the double bond will get the hydrogen. And then, itong electron na to, ibabalik niya kay halogen. So, the product for the first step will be, step 1 pa lang to ha, step 1. So, in step 1, the product will be okay, so an ion na yung bromine kasi ito, dalawang electron yan, or lone pair. So, it has 8 electrons around it. So, negative 1 na yung charge niya. So, ito yung question. Where should I place my hydrogen? Should it be placed here? Or here? Is it A or B? The answer is A. Okay, so the answer is A. You should place your hydrogen here. Why? Kasi ano sabi ni Markovnikov, the hydrogen should be placed to the carbon atom bearing the most hydrogen atom. Okay? So, yung hydrogen, dugtong mo daw sa carbon na may marami ng hydrogen. Ito. Ilan hydrogen na ito? Wala. Wala siyang hydrogen. Bakit? Ba't 0 yung hydrogen niya? Kasi, 4 na yung bond niya. So, 1, 2, 3, 4. So, 4 na bond niya. So, wala na siyang bond for hydrogen. While this one, okay, pasensya na. Okay. So, while this one, ilan yung ano niya? Ilan yung hydrogen niya? Bilangin mo muna ilang bonds meron siya. So, you have 1, 2, 3. So, you have 3 bonds. So, ibig sabihin may isa pa for the hydrogen. Okay? May isang hydrogen na nakadugtong dyan. So, ibig sabihin, if you were to add another hydrogen, this one, it should be placed here, no? It should be located here. So, doon ko ilalagay yung hydrogen ko. And ano mangyayari dito? Magiging carbocation na lang yan. You will indicate it with a positive sign. It is important for you to indicate it with a positive sign. Ayan, so positive sign. The next step, step 2. In the step 2, step 2 is just simple. Your halogen will attack the Br. And the Br will attack the carbocation. When I say attack, basically dudugtong lang siya. You will just simply connect it. You will just simply need to connect it. So the product here will be this one. Pangit ko mag-drawing ng pentagon. So hydrogen dyan, Br andun. Okay, so this is the answer. The Br should be located here. The hydrogen should be located there. Okay, so that's how you should apply Markovnikov addition. The hydrogen will be added to the atom bearing the most hydrogen. In our case, ito yun. The halogen will be added to this carbon atom, the one with the least hydrogen. Okay, so going back to the PowerPoint, our answer here should be this one. Okay, actually we can hide the hydrogen. Pwede mo na tanggalin yung hydrogen. Automatic na yan. Okay, so that should be our answer. How about number 2? Ito, hindi na ako mag-notepad. Hindi ko na papakita yung mechanism. Let us just identify where the H will be connected. Is it here or is it there? Where the Br will be connected, is it here or there? So yung hydrogen, dudugtong yan sa carbon atom bearing the most hydrogen. Ilan hydrogen nito? Wala. It doesn't have any hydrogen because it contains 4 bonds already. While this one contains 3 bonds, 1, 2, 3, meaning it has a room for 1 extra hydrogen. So wala tong hydrogen and to may isa. So that means this hydrogen will be connected here and the Br will be connected there. Okay? So the Br will be connected there. So the final drawing for our molecule will be this one. Nandito yung Br. Ganun lang. Okay? For this one, HCl. Saan dudugtong yung H? Saan dudugtong yung Cl? So, applying Markovnikov addition, yung H, dudugtong siya sa carbon atom bearing the most hydrogen. Ito, ilan hydrogen na ito? Ito, wala. Wala yung hydrogen kasi 4 yung bond. How about this one? How many hydrogen does this carbon contain? 1. It contains 1 hydrogen. So meaning this hydrogen will be added here. The Cl will be added there. So the final drawing will be this one. Okay, so ganun lang. So the hydrogen will be connected here. The Cl will be connected there. Last 2 items. We have last 2 more items. Are using the same logic? Okay. Using the same logic. Saan mapupunta yung hydrogen? Saan mapupunta yung iodine? Is it here or here? Saan yung hydrogen? Dito, dito. So, this one, how many hydrogens does this carbon contain? Meron na siyang isa. Pero ito, it contains how many hydrogens? 2. Okay? You need to practice on counting hydrogens without without drawing the Lewis structure pa. Kailangan isang tingin lang, alam nyo na yung hydrogen. So, bakit naging isa yung hydrogen na to? Kasi may 3 bonds yan. 1, 2, 3. Ibig sabihin, yung isang sobra, kay hydrogen yan. Well, this carbon contains 2 bonds lang, 1, 2. Ibig sabihin, the other 2 bonds are connected to hydrogen. So, meaning, the H will connect here and the iodine will connect here. So, the drawing should look like this. The final product. Oopsie, ayun, lumabas na yung sagot. The final product should look like this. Yung hydrogen andon, dito siya, yung iodine andito. And then lastly, HBr, and this one. No, ang gagawin natin. Okay, so ang gagawin natin is that we locate where is the carbon with the most hydrogen. Doon kakabit yung H. So ito, ilan hydrogen na ito? Wala yung hydrogen kasi apat yung bond dyan eh. So no more room for the hydrogen. How about this one? May dalawang hydrogen dyan. Okay? Kasi may dalawang bond sa kanya. Apat yung kaya ni carbon. So ibig sabihin yun, dalawa, hydrogen yun. So that means the hydrogen will be connected here and the bromine will be connected there. Therefore, the molecule should be drawn like this. Okay? So, yan yung ating mga sagot. Okay? Ayan yung sagot natin. It's the same as those shown in the slides. Okay? Next one. The next reaction, hindi pa tayo tapos. The next reaction is called the hydration reaction. So, in hydration reaction, basically you just add water to your alkene. Okay. However, the water should be acidified. Okay. So, kailangan may extra hydrogen siya. So, again, this should be acid-catalyzed. Ibig sabihin, dapat may extra hydrogen. So that is the that is the requirement of hydration reaction. It should be acid catalyzed, meaning that your water should have extra hydrogen. So it will be called hydronium ion. Okay, so hydronium ion yan. And again, acid catalyzed hydration follows Markovnikov regio selectivity. And keep in mind that the dilute sulfuric acid is only added. We don't use concentrated sulfuric acid. Okay? So, ganun lang. So, what is the mechanism for the hydration reaction? So, the first step in the hydration reaction is that the pi bond here, your alkene, will get the hydrogen of the hydronium ion. Kunin niya yung hydrogen ng hydronium ion. So it will still follow the Markovnikov regio selectivity. Okay, but in our case, the alkene is symmetrical. So pwede dito, pwede doon. Doesn't matter kasi symmetrical siya. But again, keep in mind that it will follow Markovnikov mechanism. So yun, kunin niya uli yung hydrogen. Then ano susunod? Yung water, it will attack the carbocation. Okay? So, ko-connect siya sa carbocation. Ito yung mangyayari. This molecule is called an oxonium ion. Oxonium ion. Okay? So, it is an oxonium ion. Step 3 is that yung catalyst, we need to regain that. Okay? So, we need to regain the H3O. So, we have another water molecule. Saan ang galing yan? Obviously, marami namang water sa reaction, di ba? So, maraming sources of H2O. Kaya, okay lang na maglagay uli ng H2O. So, basically, in order to regain the catalyst, meaning, yung ating water na inisinulat, which come from our solvent, kukunin niya yung hydrogen. So, the lone pair will get the hydrogen. So, kukunin niya yung hydrogen. And then, itong electron na yan, bibigyan niya kay oxygen. So, that's the results to our alcohol. Okay? So, there are 3 steps in the hydration reaction. Okay? So, the first step is the typical one. The alkene will get the hydrogen of the hydronium ion, resulting to the production of water molecule and carbocation. The second step is that the water molecule will attack the carbocation. Take note that the arrow should be drawn from the lone pair to the carbocation. Again, from the lone pair to the carbocation. So, dudugtong na yan. Tawag dito ay oxonium ion. Then after you have your oxonium ion, ano mangyayari? You need to regain the H3O. Basically, sulat ka lang ng H2O ulit. And then, the lone pair of the oxygen will be used to get the hydrogen. So, kukunin mo yung hydrogen, then ito, ibabalik mo yung electron niya to oxygen. So, you will have your alcohol. So, that's hydration reaction. Ganun lang. Okay. Next one is halogenation. So, halogenation reactions of alkenes follow similar mechanisms. Addition lang din siya, but with extra steps. No? And commonly, yung halogenation reaction for alkene only involves chlorine and bromine. Why? Kasi for fluorine, it is too violent that it is not practical to do it in the laboratory. For iodine naman, the reaction will take very long time. Okay, so that's why chlorine and bromine are commonly used in the halogenation reaction. Also, it is important to know that the halogenation reaction follows an anti-addition regioselectivity. When we say anti-addition, yung isa nasa taas, yung isa nasa baba. So that means we have a cis-trans isomerism for this one. Okay? Let me demonstrate to you what do I mean by the anti-regioselectivity. Okay, so again, just keep in mind that the alkene, okay, so yung ating alkene, it will attack one of the halogens. Okay, so this is the bromine molecule. So when that happens, ibabalik na to yung kanyang electron sa isang bromine and magkakaroon tayo ng triangle na to. Okay. So this triangle is called the halonium ion or the bromonium ion. Okay, so it will form this intermediate. Okay, so basically ang gagawin nyo nandito when you draw the mechanism, kopyahin nyo lang, no? So the double bond will get the bromine electron, babalik doon, and then itong lone pair ng bromine dudugtong sa carbon na yan. So basically it looks like this, no? Let me illustrate it with kaya ko ba illustrate dito? I have limited atoms only. Okay, let me show you using my molecular kit, no, para mas ma-visualize ninyo. Okay, so for example, this is our alkene. So this pi electron will attack one of the bromine atoms here. So dudugtong siya sa isang bromine atoms. Then kukunin netong bromine yung sobrang electron. Tanggal na siya. This is now an ion. And then one of the lone pairs of this bromine will connect to the other carbon. So this thing is called the bromonium ion. So it looks like a triangle. Let me demonstrate again slowly. Dahan-dahan tayo. So again, we begin with, okay, so ito yan. So we begin with one of the, we begin with the pi electron of the alkene attacking one of the bromine atoms. So dudugtong siya doon. So pag dumugtong yung pi electron doon, matatanggal to. Yan, tanggal siya. And then since may lone pair to na isa pa, that can be used to connect to this carbon atom. Yan, may ganun siya. Okay, so this is the ion called the halonium ion. Okay, that is what is shown in your PowerPoint. Yan. So basically, maraming nangyari sa first step. Okay, so yan, you will form your halonium ion. So it is a triangle. Okay, and the halogen here will have a positive charge. Okay, and due to its formal charge. So after forming the halonium ion, what will happen next is your Br minus will attack the backside, okay? The underside of your halonium ion. So, ibig sabihin, kung yung triangle it is pointing upward, then the bromine will attack sa baba. Okay? So, that's why it is called the anti-addition. Kung nasa taas yung halonium ion mo, itong bromine, aatake siya sa ilalim. Okay. Let me demonstrate it with you. With our models. Okay. So, let me demonstrate it again. So, once we have the halonium ion, remember, ito yung ating anion, it will attack sa ilalim. Bakit hindi pwede sa taas? Kasi bulky to. Okay? Malaki yung halogens natin, right? Okay. So, malaki yung atom na yan. So, it cannot attack at the top side. It should be down here. So, if that happens, ano mangyayari? Dugtong lang natin to dito. Okay? So, I will connect it here, dito. Ayan. Nasa ilalim na siya and then mapuputol tong bond na to. So, you have your anti-addition. Yung nasa taas, isa. Yung isa nasa baba. Okay. Let me slowly demonstrate it again. So, this is your halonium ion. This is the bromine. It will attack on the underside. So, pag umatak yan on the underside, the electron will be pushed to bromine uli. So, mapuputol yung bond na yun, producing your anti-addition product. Okay? Ibig sabihin yung isa nasa taas, yung isa nasa baba. Therefore, you have a trans product. No? May trans isomer kang mabubuo. Isa nasa taas, yung isa nasa baba. Okay? So, basically, that's the mechanism. Sir, pwede po ba nasa baba itong triangle? Pwede naman. Pwede nasa baba yung triangle. And then, yung BR, atake nga lang sa taas. Okay? So, ibig sabihin ito, pwede dito yan. Pwede ito yung nasa taas. Okay? Basta ang idea is that they should be on the opposite plane. Okay? They should be on the opposite plane. Okay? So, wag na tayong mag-mechanism, no? Ang dami nangyayari. Pero yun yung idea na bakit siya naging anti-addition. Okay? So, it will first form the halonium ion and then mag-underside attack yung ating halogen forming the anti-addition product. Isa nasa taas na halogen, yung isang halogen nasa baba. So, let us determine the major product of the following reactions. Let's first do muna. So, wala naman dito Markovnikov. The idea lang is yung isang bromine nasa taas, yung isang bromine nasa baba. Okay? So, I can write the product as this one. Ay, lumabas na lahat ng sagot. If you want to write the bromine on top, edi ano gagamitin mong bond? Ang gagamitin mong bond ay solid wedge. So, if solid wedge yung bond mo, ganito yan. Ibig sabihin, nasa taas yan. Ibig sabihin, yung isang bromine nasa baba, you will use a dashed wedge. Okay? Yan na ba yung sagot? Hindi pa. This is actually wrong. Bakit siya wrong? Kasi, if you use solid and dashed wedge, dapat, etong bonds na to, you should convert them into their corresponding solid and wedge. Solid and dashed wedges. Okay? So, ibig sabihin, if this bromine is on top, this methyl group will be positioned at the back. If this bromine is at the back, this methyl group will be positioned upwards. So, magiging ganito yan. Okay? So, just keep in mind, okay? Just keep in mind that the position of your bromine must be on the opposite sides. Yung isa nasa taas, signified by the solid wedge, and yung isa nasa baba, signified by the dashed wedge. Okay? So, ganun lang. We can do the same thing here. Okay? So, ito. Let me redraw it. So, pwede yung isang bromine nasa taas, pwede yung isa nasa baba. Okay. So, dito na lang. Natanggalin ko na yung double bond. I can place the bromine on top. Dito. Itataas ko na lang siya. Okay. Meaning the methyl group will be down here. And then yung other bromine nakaganyan lang. Ito question. Bakit po kaya hindi siya pinakita as wedges? I did not show that it is a wedge kasi hindi siya stereocenter. Hindi siya chiral carbon. However, this carbon is now a chiral carbon. It's connected to this group, the bromine, and the methyl. So, ibig sabihin, you can assign RNS configuration for this one, but it's not our concern for now. Okay? You can do that, no? Pero since this is not a chiral carbon, then you can just write a simple line. Siguro you might be asking, sir, what if yung bromine nasa likod? Okay lang. Okay? So, ganun lang. Okay? So, that's basically how you answer it now. Okay, so you can have two answers. Yung isa nasa taas, isa nasa baba. Or yung isa nasa baba, yung isa nasa taas. Okay? So the answers are shown here in the next slide. I will not walk you through all the other items. Ayan, kasi we still have many things to cover. Ayan. The EN means the enantiomer. Okay. Sorry, it is a chiral carbon pala. I'm mistaken. Sorry. Chiral carbon din siya. Okay, so as you can see, ito nasa likod, ito nasa taas dapat. So yeah, chiral carbon. I was thinking of another molecule. Okay, so yun lang. So enantiomer sila. Meaning ng enantiomer, naka-flip naman. So ito yung nakataas, ito yung nakababa. Okay? So it is important that you have watched the lecture recording which I made nitong nakaraan. So please watch it so that you will know the idea of enantiomerism. Next one, the next reaction of your alkene is the catalytic hydrogenation or the reduction reaction. So basically, this reaction converts your alkene into an alkane.